Let us now use the Venn diagram to represent the results of set operations. Let us be guided that whatever figure that we could see inside the universal set, oftentimes represented by a rectangle, are actually considered to be sets. And if we talk about these sets here, whether they are joint or disjoint, we can operate them with these four different set operations: the union of sets, intersection of sets, the difference of sets, or we also know as the set difference, and the set complement or the complement of sets. Considering this figure here in this pre-break session, let us try to determine the results of the set operations and show them as a form of a Venn diagram. For this given pre-break session, we intend to shade or put a color or fill a color on the region that could actually be part of our result. So if the case is this region here is part of the result, simply fill in with a color or shade it. If it's not part of the result, then do not shade it. Let's talk about item number one. Number one here talks about the union of sets L and E. For this given figure, set L is represented by this figure here, which is also, it also looks like letter L, and set E is the representation of this ellipse here, or the oval shape, or the oblong, which is bounded by the pink colored curve. So we are going to answer first the set operation and then represent them using this Venn diagram. Take note that if we talk about union of sets, we are talking about the combination of both of them. So if one group is to be combined by the other group, we are considering that all members of both groups are to be picked or to be considered. So if we talk about the Venn diagram, shading purposes, we are going to shade the regions that of the two different sets, whether they are joint or disjoint. They are all the parts mentioned will always be part of the union of the two. So if we talk about the union of set L and set E, let us try to shade the parts of set L, regardless of whether it's part of another set. So set L here is actually this part here, okay? How about this area here, which is given to be also the overlapping portion, or the other term for overlapping is the intersection of set L and set X. Yes, it's part of set X. However, in the first place, it is part of what set L, sorry, rather, of what set L looks like. So again, even if this is part of set X and we don't have X here for our result, it's still part of set L, so we still shade it. This is set L. And the union, its union with set E. Set L and set E are said to be disjoint sets. Just try to imagine removing set X in your, sorry for that, removing set X in your mind. If we're going to remove set X, we can see that set L and set E are disjoint. However, if we talk about union, again, we are considering both, regardless of whether they are joint or disjoint. So even if I will return the given figure earlier, we shall still shade this portion here, as this is also part of the union for set L and E. How about this area here? Similar thing to this area here earlier, even if this is part of set X, or the figure which is also in the form of X, it is in the first place part of set E, the whole figure of the ellipse. So we also shade it. So this is the union of set L and set E. If we talk about union of set L and set X, let's just try to add L. What if I will add here another figure? Okay. So if I'm going to add here another figure, and let us say this is L union X. So we shade all parts of set L and all parts of set X. Here, it's lucky for us. We're lucky enough to say that set L and set X are joint. But still, if we talk about union, we shade all. Shade this part here, part of L. This is also part of L and X. Shade it as well. And then shade part of X, shade part of X. And this area here, still part of X, even if it's part of set E. So it's shaded like this. So look at the difference between the two. In the first item, they are disjoint, but still we shade both of the sets. Here, they are joint, but still we shade both sets. This is for the union of sets. Let's proceed to the next item, number two, which is concerned on the intersection of two sets, namely set L and set X. If I talk about intersection, we are just going to shade the area which is common or the overlapping portion for the two given sets. This is set L and this is set X. Consider only the portion where the two are actually overlapping to each other. So if that is the case, we are going to shade this region here, since this region, let's use the color gray, this region is part of set L, and of course, it is also part of set X. And since intersection talks about the common region, this is the result for item number two. What if I will add another item? This is not anymore part of our pre-bake session, but just an extension. If I'm going to add another problem, and let's say I will have here X intersection E, we are now going to shade the region where the figure of X and this the figure of X for set X and the oval figure for set E overlaps. And this actually this region here, as this region is the part of the red colored X figure and also the region of the pink colored ellipse or oval figure. How about if we again add another item? This is not part of the pre-bake session, but just for the purpose of discussion. And what if we have here the intersection of L and E? L and E are considered to be, just like in number one earlier, they are considered to be disjoint sets. So from the name itself, disjoint, they are not joint. Therefore, they do not share a common region. Do not answer this region here because this is the region of X, not of L nor of E. So if we are going to consider two sets which are disjoint for the intersection, we will have no shading because in set operations, if two sets do not share common elements, the intersection is considered to be an empty set or a null set, which also means no element could be found. So for shading of Venn diagram, no shading. This could happen if there is no intersection of sets. Let's go to item number three. Now, item number three and item number four are for set difference. For set difference, we're just going to think about this logic. Imagine yourself having an apple and there is a portion, a part which is not edible because it might be rotten or probably too ripe. What will you do for if you don't like eating that part? Definitely, some of you might get a knife and cut that portion out. Imagine that apple with that part taken away. That is how our Venn diagram will look like if we talk about set difference because we are removing, taking away a portion of our set. That is actually also the idea behind the symbol of the apple, which is the uh, common for our mobile learning devices. Okay, a portion was taken away. So with that thinking, let's go to set number three rather. We have e minus x. So if we have here e minus x, this would mean the given first set or the minuend set e, which is the oval figure, some of its parts will be taken away. And what are those parts? Those are actually parts of the second set, which is the subtrahend set here, set x. Supposedly, if we are just going to shade E, again, if we are just going to shade E, we will be shading all of this. However, we are going to remove a portion of set E that is also part of set X. And what is that portion? This portion here. This portion here is a portion of X. And then instead of shading it, since it's part of set E, we are removing it because we are removing here set X. So remove that, remove the shading, and your answer looks like this. Again, looking at the figure, it almost like a complete figure, but with reduction or some parts they have been taken away or removed. If we are going to interchange the operations, x minus e, our concern now is set x. This would mean that we can shade all first, set e. You may use a pencil for this because we're just going to erase it. This is x, not yet the x minus e. So for this is for set x. But then again, we are going to remove a portion of it, which is part of set e. And this red region here is part of set e. So by removing the shading there, your answer for number 4 looks like this. So what is left is most probably it will look like a brick on your Tetris game, if you're familiar with it. Okay, so looking at number 3 and number 4, some parts of the original set was taken away or were taken away. So if we are going to add here another item just for discussion purposes, what if we have here L minus X? We are going to shade first set L, the entirety of it. So shade set L, including this one. But the last portion that we have shaded is part of set X, the set we are going to remove from the given set. So by removing that, this is how L minus X looks like. If you're going to interchange the operations and say we have here set x minus L, our concern again is the whole set X, not anymore L. So shade everything, X, X, shade here, X, and here as well. But we are going to remove the portion which is part of set L, and this is the area here. So we can remove that. Let me remove everything first. And I'm going to shade this area here. So this area was removed from set X as the operation X minus L commands or requests us. Finally, if I will add another one for a while, just for discussion purposes, not necessarily part of this pre-break session. If I do have here the operation L minus E. So I'm going to shade the entirety of set L, which also includes this. But we are going to remove set E. Notice that set E and set L are disjoint. So no other region of set L is also part of set E. So if we're going to remove set E, the answer would be L itself. Do not answer unshaded because unshaded would mean we are removing everything. To answer this, again, we shade set L, but there is nothing that we could remove since again, set E is not connected to set L. Imagine this as an apple earlier, and then you're going to remove a portion that you don't like to eat because it's too ripe or probably rotten portion. However, your apple is as good as it could be. In short, no part is rotten, no part is too ripe. That would mean there's nothing or there's no part of that apple that you could remove because all of that apple is as good as it could. This is similar to this. There's no common region that could be removed, no region which is rotten. Let's proceed to the last item. Last item, let me increase it here, corresponds to the complement of L. If we talk about the complement of the set as compared to the universal set, we are talking about the elements not part of that set but is part of the universal set. In other sense, we are going to shade the regions not part of the given set but still part of the universal set. I'm talking about here set L. If we are talking about set L, again, this is the region for set L. But if it's complement, we are going to shade the other areas but not L. So remove the shading for L, but shade all other regions. I'm talking about this region here, because this is not part of L. This and this region is here are also not part of L. How about this last part? The last shaded part that I did is part of set X. However, in the first place, it's part of set L, so it should not be shaded. Look at our result. All parts of the universal set, but not L, is shaded. Imagine this as the negative mode of your cameras in your phone. When you take a picture but set it as a negative mode, what will happen is that the darker portion will become lighter and the lighter portion will become darker. Imagine this as that. Supposedly, we are going to shade L. But since it's L complement, imagine this dark region to be lighter and the light region here would be darker. So if you're going to return it, we are going to shade this area here, here, here as well. This is also the reason why the universal set is very important for set complement. Imagine if there is no universal set here, meaning there's no rectangular figure. Let's do it this way. Imagine if there's no rectangular figure here, and then we're going to use set complement. So by shading the region which is not part of L, this is what will happen. All other parts, even all the other parts of other items, will be shaded. Why? Because we don't have the universal set in the first place. This is why the universal set and the complement of the set must come together. There could be no complement of a set if there is no universal set given. So returning to that, again, this is the reason why we have this rectangular figure which corresponds to the universal set. And again, shade here, 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 as well as here. Looking at that, you can close one eye and then you could see a light figure of L. Let's try to have another here. And what if this is X complement? That would mean shade all other parts, but not of X. So shade all other parts here, here, as well as here, but do not shade this area because this is part of set X, nor this part. This is your X complement. You might see a floating figure of X. And definitely, if we could try the last part, and you could say E complement, we could see the final result where this region is only the light region. Let's try. Shade this part here, L, shade the X. Shade this, shade this one? No, because even if it's part of X, it's also part of E. Shade other regions, but not of E. So this is how the set complement will look like. If we're going to summarize all of these four operations, the union of set talks about the combination of all sets. In short, shade all parts of both sets. Number two, set complement. We have this region here. Okay, this is the part which is common to both sets. If you would like another real life example for set complement, imagine this. There is a bench which is just painted a while ago. So the paint is not yet dry, it's still wet. And when you're going to try sitting on that bench and standing up probably later, you will see a portion of uh, your butt portion which has color similar to the color of the bench. That colored area in your pants rather is considered to be the intersection because that is the area where your butt or your pants rather intersected or overlapped with the area of the bench, still with wet paint. That is an example, a real life example of intersection. So that portion only. For set difference, imagine if an apple or any other fruit with a part that you don't want to eat, so you're removing it. So it looks like that a portion is taken away. And finally, for our set complement, imagine the negative mode of your cameras when you take a photo. The lighter part will become darker, and the darker part will become lighter, unveiling a floating image, a floating of this light image. So hopefully you can use all of this. Again, we extended with our items as long as it's more comprehensible to you right now. So wait for the next video. Bye bye, everyone.